Welcome to lesson 2 for the week of May 18th. This is our last chemistry lesson for the year. Mostly today we are going to be reviewing types of reactions and then learning about ways to speed up chemical reactions. So the 5 types of reactions are things that we learned about first semester. Okay, so if you need to look back at your Unit 5 notes from our practice, you can. But just as a quick recap, the first type of reaction we learned about was a synthesis reaction. So much like photosynthesis, we're talking about combining. So here you see an example of a synthesis reaction. You have 2 reactants, A plus B, forming one product. Okay, so you have yellow plus blue to make something that's green, a combination of the both. The exact opposite of that type of reaction is decomposition. Decomposing means to break apart. So you have one reaction, you have your green whatever, breaking apart into its components, the yellow and the blue. So you'll notice that they're opposite. For a synthesis reaction, we have a plus sign on the left, but not on the right. Okay. Decomposition, you don't have an addition or a plus sign on the left, but you do on the right. Okay. That's how you can tell the difference. Next type of reaction is a single replacement reaction. In class, we called this the got your man reaction. Okay. You have A, this girl is single, and then B is dating C. Okay. A is going to come in here and break up and replace this couple. So B got dumped, and now A is dating C. Okay, so you did have a replacement happening. Okay, C is dating someone different before and after, and then there is someone single before and after as well, an element that's single. Similar to this would be a double replacement reaction, where you have 2 couples and they're switching girlfriends or whatever. Okay, they're switching metals, really, is what's happening, or cations. So A and B are together, and then afterwards C and B are together. But no one is single. There's no element that's by itself before or after. And then the last type of reaction we talked about first semester was combustion reaction. So combustion reactions are when a carbohydrate reacts with oxygen to form carbon dioxide and water. Okay? We also call these CHO reactions, CHO, because they only have the elements carbon, hydrogen, and oxygen. Okay, so like C1H4 reacts to form this, and the products are always carbon dioxide and water. Then remember last lesson we learned about neutralization reactions? A neutralization reaction is a double replacement reaction. It's a special kind. Okay, so let's look at this graphic. Okay, this was right from our Unit 5 notes, where it's the same thing. It's a more kind of defined definition if you want to pause, if you feel like you need more review and look over this. And there's also this pictograph over here on the right. Sample problems, okay? So we want you to go through and see if you can identify from these chemical equations what type of reaction it is, okay? So for number 1, I see pure hydrogen plus pure oxygen making water. That would be a what? See if you can answer it on your own. Synthesis, right? I have 2 reactants and then only one product coming together. If you want to pause this and go through the rest with your best guess, that's a great idea. Otherwise, I'll just keep going, let you work at your own pace. So number 2 looks like a double replacement reaction. Okay, I have a compound, and then they switch. So instead of H being bonded onto F, Li is bonded onto F. And you're right, this is a double replacement reaction, but it's also a neutralization. So that would be the better answer, because you have an H acid with an OH base, and then you have something ionic and water. So water and salt. Acid plus base, that's how we know it's neutralization. Number 3, I have CH3 plus O2 makes carbon dioxide and water. CH and O means combustion reaction. Okay. Number 4 also looks like a double replacement reaction, very similar to number 2, except I don't see an acid or a base. So I would say just double replacement for number 4. Okay. Number 5, I have sodium chloride breaking up into sodium and chlorine. 1 reactant, 2 products, that's breaking apart, so decomposing or decomposition. And then number 6, acid plus base making HOH. So writing it like this, HOH, it really is the same thing as H2O. Okay, it's just annoying seeing it written like this, but it's the same thing. You're going to see problems like this on your homework check, and your end of the week quiz. Great. All right, the last thing we have to look at then is this video on 5 ways to speed up chemical reactions. So I'm going to play the video. I need you to pause the video as needed to try and get all 5 of these down, because it's going to be on your homework check.
Meet our chemist, Harriet. She has a chemical reaction that needs to occur more quickly. Our chemist has some processes at her disposal that can help her speed up her reaction, and she knows of 5 ways. And to remember them, she thinks back to her days as a high school student, and the day she got a date for the dance. Harriet was in high school studying between classes. She had lost track of time and was going to be late to class. Unbeknownst to her, Harold, who was just around the corner, was running late too. They both sprinted to class, and as it happened, sprinted directly into one another. Now, this was no small collision. They ran squarely into one another in such a way that he knocked the books right out of her hand. "I'm sorry," he said. "Let me help you with your books." He kindly helped her recollect her belongings and politely offered to walk her to class. And you'll never guess who went together to the dance later that year. Yep, those two. So as we can see from this example, the key to getting a date for the dance is to collide with someone and knock the books out of their hands. Now, you're probably already aware that not all collisions lead to dates for the dance, thankfully. The collisions must have 2 important characteristics. 1, correct orientation that allows books to be knocked from one's hands, and 2, enough energy to knock the books out. Shortly after this incident, Harriet decided to tell me, her chemistry teacher, all about it. I noticed some interesting parallels between her story and chemical reaction rates, which happened to be what she was studying in the hallway the day of the collision. Together, we decided to set out on 2 missions. Harriet wanted to help all chemistry students and chemists remember how to speed up the rate of chemical reactions, and I, being the nice guy that I am, decided to make it my mission to help create educational environments in which more book-dropping collisions can take place to increase future chemists' chances of getting a date for the dance. In order to facilitate this improved dance date-getting process, I propose 5 changes to all schools that parallel Harriet's 5 ways to increase chemical reaction rates. First, I propose that we shrink the size of the hallways. This will make it more difficult to safely navigate the hallways and will cause more collisions than in larger hallways. And by increasing the number of collisions, we increase the likelihood that some of those collisions will have the correct alignment and enough energy to create a date to the dance. Now, chemically speaking, this is equivalent to lowering the volume of a reaction vessel or a reaction mixture. In doing so, the individual particles are closer together and more collisions will occur. More collisions means a greater likelihood that collisions with the appropriate energy and configuration will happen. Second, I propose increasing the overall population of the school. More students equals more collisions. By increasing the number of particles available for collision, we create an environment where more collisions can take place. Third, we must reduce the time allowed between classes. Heck, let's just cut it in half. In doing so, students will need to move more quickly to get from one class to the next. This increase in velocity will help make sure collisions have the appropriate amount of energy necessary to ensure book dropping. This is analogous to increasing the temperature of the reaction mixture. Higher temperature means particles are moving faster. Faster moving particles means more energy and a greater likelihood of reaction causing collision. Fourth, students must stop traveling in packs. By traveling in packs, those students on the outside of the pack insulate those in the middle from undergoing any collisions. By splitting up, each student has some more area exposed that is available for a collision from a passing student. When particles travel in packs, the surface area is very small, and only the outside particles can collide. However, by breaking up the clumps into individual particles, the total surface area is increased, and each particle has an exposed surface that can react. Fifth, and finally, we hire a matchmaker. Is this colliding and book dropping too violent? Is there an easier way to get a date that requires less initial energy? Then a matchmaker will help with this. The matchmaker makes it easier for a couple to get together by coordinating the match. Our matchmaker is like a catalyst. Chemical catalysts function by lowering the activation energy. In other words, by lowering the energy required to start a reaction. They do this by bringing 2 particles together and orienting them correctly in space so that the 2 can meet at the correct configuration and allow a reaction to take place. So, to sum up, if a future chemist wants a date for the dance, he must collide with another person and knock the books out of their hands. And if a chemist wants to make a chemical reaction occur, the particles must collide in the correct orientation with an appropriate amount of energy. And both of these processes can be accelerated using the 5 methods I've described.
Here we go. Okay, so number 1, shrink the container, increase the concentration so that the chemicals are closer together. Increase the number of chemical particles, which again is very similar to increasing concentration. Make them move faster. Okay, that means heating up the mixture, crushing the mixture, okay, so that there's no big chunks, and then using a catalyst. In biology, you might call this using a catalyst as well. Okay, all right, thanks y'all.